inspired by everybody's throwing that word around, and it just seems like, oh, I'm going to virtualize this and virtualize that. I just want to hit the high points of what the core is and why it is and all the different types. So, yeah, it's not in the dictionary. I'm sure you guys have typed it, and it's in nobody's spell check, and it's just irritating because I type it 1,000 times a week. Anyway, some of the stuff they virtualize, hardware, memory, software application, all these different things. Everyone wants to be virtual this and virtual that because it's the buzzword, and click, buzz. Anyhow, so this is what I'm going to talk about today. The different layers of essentially OS virtualization, which is kind of the original, virtualization back when virtualization was cool. Anyhow, so basically it's all about running your code on CPU. And back in '74, these two guys wrote a specification of sort that said, to be true virtualization, non-privileged user code runs on the CPU natively. And privileged code gets trapped or binary translation or some other method. And they also say that to be true full virtualization, it should be recursive, which means here's a VM, I install an OS, put the VM on it, another VM, another, so you just keep going down, like taking a picture into a mirror. Not that you would ever do that, but that's the test for the spec. Okay. So for full virtualization, so it is spec compliant with those two dudes. The OS has no knowledge that it's virtual. So basically, if you get the CD-ROM that has the operating system, you should be able to install it natively, and it'll work out of the box, and it doesn't know that it's virtualized. It uses binary translation for those privilege calls, and on a physical host, you will have multiple kernels. So whether it's hypervisor or not, the host OS, your Windows box, Linux box, whatever, all of those kernels are running independent of the other ones, sharing the root namespace, essentially.
What's the difference between hosted and hypervisor?
Well, hosted is you have an OS on your machine like Parallels, you have OS X installed on your laptop, and you put Parallels on, and then you put Windows on. So there's the host OS, and then the guest OS. So you're running a full stack of an operating system on the hardware or bare metal. Hosted is you're running a hypervisor, which is still an OS because it has to bootstrap the VM space, but that OS is streamlined and trimmed down. And
only for virtualization. Yeah,
it's all it's designed to do is for virtualization. So ESX is based on Red Hat, but Red Hat's just there to boot the VMware kernel, which then in turn runs all of your VMs. So the Red Hat just sort of sits in the background, and it's really idle. It's only a couple hundred megs of RAM, and it doesn't take a lot of space. They're going towards ESXi, which basically boots off a thumb drive, and it's essentially an even more stripped down version. But it is an OS in the truest sense of the word. But they call it hypervisor because that's a cool buzzword marking people on. So these are some examples of hosted versus hypervisor-based ones. And IBM's virtualization stack has many different types of VMs. So the L part is the hypervisor-based full virtualization, and that's PNG compliant. Paravirtualization. So paravirtualization is the OS does know that it's virtualized. It's a special port of the kernel that knows, hey, I need to make this system call, and it makes a system call, and the host or the host OS understands. So it's kind of shared, but that's why they're calling it paravirtualization. The OS presents special devices, and it is multi-kernel again. So there's many copies of the operating system running on the same box, even though they're slightly modified from the original version. But most of the packages and the user land programs that you're going to run in paravirtualization don't really care because they're all user land anyway. And any system kind of calls that they do get trapped by the host OS and gets executed. So what's happening in the industry is that full virtualization, which is what VMware is, and Hyper-V and all these other guys, is they're sort of merging paravirtualization with full virtualization, and they're doing that through things like VMware tools. So VMware is PNG compliant. It is the OS doesn't know it's virtualized, but now once you have the OS running, you install VMware tools, which is essentially a bunch of drivers that say, oh, don't use this emulated NIC card, use this special VMware NIC card, which is essentially saying, okay, that's not native, it doesn't follow the P&G spec, so here, use a special card. Now it outperforms the emulated, NE 2000 or whatever they used to emulate back in the day. So Hyper-V is doing the same thing with synthetic drivers. So there is full virtualization, but they're adding some packages and some software that's making it para-virtualized like. So they kind of sit in both categories. But anyway, Zen and KVM, so all your Linodes and all that stuff is all para-virtualization. Hardware assist. So I don't know if you guys remember back in 05, 06 when Intel and AMD launched the -V chips with all the virtualization extensions. Well, what that basically was, and IBM's been doing it, and Sun's been doing it for a lot longer. Basically what that was some special CPU instructions that automatically track those privileged calls and say, hey, instead of having to binary execute this, I can understand that that's going to be a trapped call and run that over here on your behalf, and it's done in hardware. The problem is in the x86 space, AMD and Intel, VMware and most of the virtualization companies have gotten so good with binary translation because they translate a binary instruction and then they cache it. It's still faster than the hardware acceleration doing it all in software. So even though these extensions are there, VMware doesn't really use them too much because binary translation is faster, essentially. So then that brings me to operating system level virtualization. So that's, typical examples are change root jails, BSD jails. In this, the kernel, it's not really multi-kernel. There's only one main kernel. You can start up a guest VM, what they're calling a VM, but it's really just a sort of a read-only view to all the kernel libraries. So you're booting another copy of it, sort of, but it's just the guest OS or the host OS is running all of these actions for you on its behalf. It's almost like IBM calls it a workload partition, and that's the best terminology I've seen to design it. It's kind of separate from your main kernel. It's got its own memory, and it's got its own network, and all that stuff, but it's still running on the same box. If the guest host crashes, or somebody does something in your little area, it goes away. Anyway, it's like a guest view of a single kernel image. So I wanted to leave the rest of the talk for questions on that, and then I was going to talk about some other cool stuff that's going on in the space, some of which we did in the previous session if you were in there. vCloud Director. Does anybody have any questions on the first stuff? So vCloud Director is this thing that VMware just came out with, and it's essentially a framework for allowing providers, like big providers like Amazon, and there's a bunch of companies that are getting ready to do it, and they're going to be able to give you regular VMware style services build out like the Linode. If you guys have set up a Linode box, it's going to be like that. You pick the CPU you want and the hard disk you want, upload your ISO image, and boom, run a VM, just like it was ESX. So they have that framework there for secure multi-tenancy, SMT. Virtual desktop, we're seeing a lot of this in the space, people doing virtual desktop, which basically is you got a VMware box or somebody's VMware box, and you put Windows XP or whatever your desktop OS is, and you have some thin client that the client actually connects to the VMware instance, or the VM instance, and that's their desktop. But it runs on a server, it's in the data center, it's clusterable, failoverable. One disk image to rule them all. We're doing a deployment now for a pretty big credit union in the Tampa Bay area, and they've got 600 desktop seats, and there's one copy of Windows XP. Well, it's going to be Windows 7, but one copy. So the first guy boots up, and he gets a Delta file of that copy. So his changes to the OS go here, and then the second guy gets another Delta copy, but the original image is all read-only. And then that does that 600 times, which is really kind of cool. From a disk space perspective, you don't have to have a 40 gig C drive 600 times. It's once, and then just the changes. Other cool stuff you could do is non-persistent VMs, to where when you log out, it goes back to what it was before you logged in. So it's a great way to get around the virus problem. And then another thing of virtualization that kind of is virtualization, but people aren't really saying it, is things like Heroku, where it's like, it's virtualized, but it's abstracted so many layers, and it's just an application framework virtualization. So it's like, you want to run a Rails app on Heroku, well, it's just this. Well, that's running on a Linux box, and that's running an EC2, and that's running on some hardware, but it's still virtualization, but at an application level. So just some cool stuff that's happening. Anybody have any other questions? Or I knew this was only going to be a 15-minute talk. Right?
Is there really any, I mean, you talk about virtual desktop, and I just can't, help but think back to the old days of the mainframes or the terminal.
That's it. It's going back.
Yeah.
Circle back. Yeah.
Fantastic.
What's old is new again. It's exactly that. These thin clients are zero clients that have no OS really, or a tiny little Linux kernel, and all they do is turn on, get an address in remote desktop or PC over IP to their VMware instance, which is a Windows XP box or whatever, and boom, full screen. They don't know the difference. No moving parts, no hard drives, no nothing. So yeah, it's basically 3270 terminal sitting on your desk. Back to that.
In color.
In color. You had a question? Somebody over there?
Yeah, what about performance of the different types of virtualization?
So if you go to full virtualization, when VMware first started doing this, like in the late 90s, there was probably a 20 to 25% hit as far as the overhead of doing virtualization. The latest versions now are down to like sub 10 for full virtualization. They've got so good at binary translation that it just hauls the mail. And the speed of these servers now, it's just, you don't need it. It's always a memory bottleneck. It's never CPU.
So what kind of things would you not virtualize?
The only thing I wouldn't virtualize is if you had some kind of, what's that? StarCraft 2. Video performance. Is a server with like some sort of special hardware card. Like let's say you got some sort of fax, modem card, whatever BS. People still use fax these days. Gavin didn't test it out. So that would be the thing I wouldn't virtualize. Otherwise, I would virtualize all of it. Period. End of story. You only get one question. You virtualize the questions.
Because what if you have something that's very hardware, or very, very dangerous to the hardware? Something that beats it up, like a database server. Large server transactions.
Still do it.
You would still do it.
Absolutely. Absolutely. Because it's just portable. It doesn't matter what the hardware is. Hey, this is AMD with these chipset and blah, blah, blah. Here's my VM. I'm just going to pick it up and move it over here completely for hardware. Replicate. Your DR solution is a file. Take that file, put it in a DVD, boom, there's your server. I've got customers that do, I like to think I coined the term, just-in-time DR, where typically you'd say, okay, I get this whole stack of servers and all my stuff's running here, and then in order to be resilient in the event of a giant failure, the place burns to the ground, I got this whole stack of servers and all the same shit over here. Well, now we virtualize, all the machines turn into files. Basically files. I mean, it literally is a file. So you take those files, replicate them to your offsite storage, and but you don't have servers to run them on. And depending on their business logic and what their business says, oh well, if the place burns down, we can be up in 4 or 5 days. We're okay to be down for that long. Or they may say I can be up in an hour, and then it's a different story. But for businesses that say, you know what, if a hurricane comes through Tampa and wipes the place clean, I'm okay if we're down for a week. So in that event, you just say, put storage out in a remote place, replicate your VMware. But when that event happens, call Dell and say, hey, I need 4 such and such machines with this much memory, frickin' overnight the son of a bitches, and they go here, you install them, you put VMware on them, it takes like 20 minutes to stand it up. And then run your OSs because they're already there.
We're even seeing, for instance, our data center here in Tampa, we have dedicated rack space, but they also offer virtualization. So we're looking at, and we've got 2 data centers, one in Tampa and one in Charlotte, North Carolina. And we've got exactly that. We've got a stack in Tampa, we've got a stack in Charlotte. We're saying, well, why are we paying for the stack in Charlotte? Why don't we just do what he's saying is, be able to call up the data center in Charlotte and say, hey, by the way, I need these 6 VMs booted into your virtualization center in Charlotte for the times when I need them, and I'm only paying them pennies instead of thousands for the
The
hardware.
hardware that's sitting there idle up.
Yes.
Anything else?
So I really like this idea of app framework level virtualization. You're seeing it with S3, and there's a lot of Heroku add-ons, and they're doing clouded and background processing. Where do you see that really going here? Because we started with machines, now we're going to the app level. Do you see that kind of taking off or going back?
Absolutely. There's a couple companies that do application virtualization for Windows. So let's say you have and you know where I see it? IE freaking 6. People are like, I'm running Windows 7 and I just can't run IE6, but I still have to freaking test with IE6. And I want to set it on fire, but I still have to test it. What you can do is you go over to your Windows 2000 machine and you run this application virtualization. What it does is it boots the app, runs through all the code that the app's going to use, and it grabs the DLLs and all the foo and all the bullshit it needs to run, and it puts it in a kind of a jar file, for lack of a better term, and then it takes that jar file and runs it on Windows 7. It doesn't matter what the platform is. And it sort of runs in, and it's like almost like a change root jail. And here's IE6 running in this space with some DLL from '94, and it's fine. So they're doing that with Windows apps, and I see application on the virtual. I mean, Citrix has kind of been doing that for a while. It's sort of a method, but yeah, I totally see it to where there's people don't care about the OS. They just want their freaking Word to start.
Yeah, normal libraries, here's a REST API. That's how you interact.
Yeah, exactly. That's
just
just
access it
use
from
this.
anywhere, stand up as many as you want, scale it.
Yeah, stop doing it wrong.
You might be good at that.
In that vein, I've seen, for a while, there's been like websites that will take like screenshots of your site and all these different VMs and all these different browsers and show the screenshot. But I've seen lately, like literally you go to a website, click a button, and it will start up a VM in the background on their site, on their servers, and they'll bring you an application. And it's for browsers, for browser things.
Yeah.
So you want Opera on Mac,
Boom.
OS 9?
And that's what it is. That's totally what it is. And what they're doing on the back end is they still have a whole OS and all that, but they're just showing you that.
Exactly.
Yes, sir.
So back on your instant or DR on demand.
Yeah.
So I want to be able to run something like VMware virtualization in my stack in my data center that's mine, all mine. But I want to be able to go to somebody like Amazon for on-demand capacity or on-demand DR. But Amazon's running their own virtualization style, and I'm running VMware, and there's no way to bridge those graphs.
vCloud Director, they just announced it at VMworld a couple months ago.
But it seems like from the sort of the enterprisey or sort of do-it-yourself virtualization on the server level, it seems that VMware seems taking over that.
Yeah, absolutely.
Space.
In the enterprise companies that run their own data centers, they're looking at EC2, but if they're doing virtualization, they're using VMware. It's the 800-pound gorilla. That's just what they're using. Unless they're a Linux shop, and then they're probably using Zen or one of the other pair of virtualized boxes. But yeah, vCloud Director is to solve that problem. People are saying, I have this data center and I love it. It's so cool, but I don't want to have a DR site. It's like, stop reinventing the wheel. It's like you have these small and mid-sized companies that it's just expensive to freaking have a data center. You gotta have cooling and UPSs and all this power and all that shit's expensive. I mean, the freaking racks are $1,000. It's just, stop, put the bricks down. I just need to run my stuff. And I don't want to be in the business of having a giant data center because you're gonna do it wrong. The only people that are doing it right are like Google and Amazon. Everyone else is doing it wrong. Everyone. I've been in so many, it's insane that they're all doing it. So anyway, that's what's going to happen. It's just going to go in that direction. Anything else? Nothing?
Virtualization.
Yeah, I need my video data set station.
What's that?
Virtualization is in the OS section.
Is it?
Yeah.
I went to dictionary.com and that's where I got that. So.
One last question. vCloud Director, does it have an EC2 programmatic interface? I know Eucalyptus, the open source project, acts just like EC2S, and
They
actually have an S3 layer that acts programmatically exactly the same. You can use the same tools.
Yeah, they have, oh, and one other announcement before you go, Marshall. I know you're not a VMware guy, but I'm going to start working on a OS X native VMware client. So, Gavin and I are anyway.
Really?
They have what's called VM API, and it's kind of limited right now, but basically it's Hey VMOS, I'm gonna shut you down, so write your shit to disk, and I'm gonna GTFO. You know, you're done. I'm gonna move you or whatever. You know, they used to do that back in the late '90s in you know, VMware. They're like, how do I trick the OS into flushing its cache? And they had like memory ballooning, where it would like take this thing and just, you know, it was mallet, go, 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 go. And all of a sudden the OS is like, holy shit, this program over here is chewing up a bunch of memory, flushing all this shit to disk. And it tricked the OS into flushing its disk because Windows is stupid. So this VM API is going to fix a lot of that stuff. So they have it published now, but some of the stuff it does is just kind of lame. It's like flush disk and clear buffer, but it's going to be pretty robust, like, you know, suspend or, you know, change these settings, be able to manage it from outside the OS itself, so you don't have to get into the console. So, neat stuff. What's happening? That's it? Cool.